Today we're going to talk about how to find horizontal asymptotes. First, let's talk about the steps to find horizontal asymptotes. Step 1 is to put the equation in standard form. And standard form is the y equals or f of x equals. Step 2 is we're going to multiply out or expand the factored polynomials. Step 3 is we're going to remove everything except for the terms with the biggest exponents. These are the dominant terms, and these are the ones we want to look at. Step 4 is we have 3 cases to determine horizontal asymptotes. First, let's recall what a typical rational function looks like. F of x equals p is just some number coefficient, x to the n being any exponent, and q to the times x to the m. So q is any coefficient number and m is any exponent. So in case 1, if the largest exponents are the same in the numerator and the denominator, so we have n equals m, then the horizontal asymptote is the ratio or the fraction of the coefficients in front of the largest exponents. So it's going to be y equals p over q. Case 2, if the largest exponent in the denominator of the function is larger than the largest exponent in the numerator, so if m is greater than n, then the horizontal asymptote is y equals 0, the x-axis. Case 3, if the largest exponent in the numerator is larger than the largest exponent in the denominator, so if n is greater than m, then there is no horizontal asymptote. Let's do an example. So example 1, f of x equals 3x minus 1 times x plus 5 over x times x minus 4. So step 1 is standard form, and it's already in standard form. So step 2 is to multiply out the polynomials or expand it. So we're going to have f of x equals, when we multiply 3x minus 1 times x plus 5, we get 3x squared plus 14x minus 5. When we multiply x times x minus 4, we get x squared minus 4x. And step 3 is to remove everything except the terms with the biggest exponents. And so we're going to have f of x equals 3x squared over x squared. Step 4, we're going to determine our horizontal asymptote. So which case do we have? We have the exponents are the same, so we have case 1. So our horizontal asymptote is going to be y equals p over q, which is 3 over 1, which is y equals 3 is our horizontal asymptote. Now let's work 2 more examples. Example 2 is f of x equals x cubed minus 27 over x squared minus 4. Step 1, put the function in standard form. It already is, so we have a check. Step 2, multiply out and expand any factored polynomials. It's already expanded, so check. Step 3 is to remove everything except the terms with the biggest exponents. So we're going to have f of x equals x cubed over 2x squared. And step 4, we're going to determine which case we have. So our exponent on the numerator is greater than the exponent in the denominator, so we have case 3, and so there is no horizontal asymptotes. Example 3 is f of x equals 2x squared minus 2 over x cubed minus 2x squared plus x. Step 1 is to put it in standard form, check. Step 2 is to multiply out or expand any factored polynomials, already done, check. Step 3, remove everything except the terms with the largest exponents. So we're going to have f of x equals 2x squared over x cubed. In step 4, we're going to determine which case we have. Our exponent in the denominator is greater than the exponent in the numerator, so that is case 2. So we have our horizontal asymptote is y equals 0. And so we've done an example of each case. So I think you know how to determine horizontal asymptotes.